Alright, now let's take a look at the concepts of solving nonlinear inequalities. Let's look at nonlinear inequalities. These are much more complicated than the linear ones that we've seen in the past. Now again, inequalities are what? Greater than, less than, greater than or equal to, less than or equal to. Now again, these are much more challenging than what we've seen in the past, because the solutions to these nonlinear inequalities are going to be a different sets of real numbers here, right? Because there are more complications in terms of trying to solve these types of inequalities. But basically, we'll do it through a factoring here, if you will. Here's what I mean by the complications of these types of problems. For example, take a look at this nonlinear inequality. Let's say we want to solve the following nonlinear inequality. Let's say something like x squared, let's say minus x minus 2, greater than or equal to 0, for example. All right. Now, in other words, what numbers will satisfy this inequality? What numbers do I plug in for x to make it greater than or equal to 0 if I plug it into this expression? All right. So that complicates matters here a little bit. Now, but the key in terms of figuring this out is to use factoring, and that means what? We're going to factor this left-hand side polynomial here. So let's go and factor this. This is an easy factoring problem. So x minus 2 and x plus 1, if I factor it, right, greater than or equal to 0. Okay. Now the key is what then? We need to analyze each factor carefully in terms of what sign each factor will give for a number I plug in to make the product bigger than or equal to 0. Okay, so we're analyzing this product of x minus 2 times x plus 1. Now, to analyze this product, what we're going to do is what? We're going to, first of all, figure out what makes these two factors equal to 0, right? So, again, we've done it already in the past, right? Just simply set these factors to 0 and figure it out. So, let's call those the boundary values. Okay, here's what I'm going to call those the boundary values, because we're going to put them on a real number line. So the boundary values are what? Are what makes these factors equal to 0. Now, to figure out the boundary values, just set these factors to 0 and solve. So in other words, the boundary values are going to be what? X equal to positive 2 for the first one, right? And negative 1 for the second one, right? So I'm going to analyze this product right here by making a real number line, by drawing a real number line on here, all right, and identifying these two key values in the appropriate order, of course. So negative 1 is here, for example. Positive 2 is here, all right? Now, let's analyze this product here. So let's put this product on the side here, on the left-hand side. So x minus 2 times x plus 1, all right? Now, we have basically, how do we analyze this? Well, if I set up my number line like this, you can see that there are 3 regions I need to test the sign of this product. All right. So how do we test these three regions? Well, the key is to pick numbers in each of these 3 regions. Pick a number in here. Number in here are what? It's going to be less than negative 1. Give me a number in the middle here. What's that? What's between negative 1 and 2? Well, how about 0, for example? Pick a number in this region. What's a number bigger than 2? Well, how about 3, for example? Right? So basically, we're picking values in each of these 3 regions, right? So region 1, region 2, and region 3. 3 regions to test the sign of the product. So let me say test the sign of this product. This product being what? Being the x minus 2 times x plus 1. Test the sign of this product in each of the 3 regions. All right. So let's go and pick numbers in here. Which again, so give me a number less than negative 1, such as negative 2, for example. Give me a number such as 0 here in the second region. Give me a number such as 3 in the third region. And what is the sign going to be? In other words, if I pick a number in each of these 3 regions, do I get a positive number for this product? Do I get a negative number for this product? right? So let's answer that with actually plugging the numbers, right? Actually doing some work on the side perhaps, right? So let's do that. All right, so let's look at region 1 first of all. So give me a number here. So I mentioned what? What's a number less than -1? Well, how about -2? -2 is in the first region, right? So let's let x be -2. All right, let's plug it in. Plug it into this product. So we're going to get what? We're going to get -2 minus 2, right? And -2 plus 1. All right? And what's that going to give me? Well, that's going to give me -4. -4, that's a 4 right there. Sorry about that. All right? And that'll give me what? -1 here, right? -2 plus 1. So what is -4 times -1? Isn't that +4? Right? So this is a positive number. Right, positive. So in other words, if I pick a number in the first region, such as -2 for x, and I plug it in, this product will be what? A positive number. So let me put a plus down here. Put a plus in the first region. So any number I choose in the first region will give this product a positive result. All right? How about 0? Let's pick 0 in the second region. 0 is in the second region. Can we see that 0 is between -1 and 2? All right? So again, we started by factoring the left-hand side, and from there we determined the boundary values by figuring out what makes these factors equal to 0. Well, 2 and -1, as you can see, as we solved these types of equations in the past. All right? And then we put these boundary values on the number line. So -1 is here, 2 is here, and then we're gonna. So that breaks up the number line into 3 regions for us to test. So we're going to pick numbers in each region, 1, 2, and 3, to see what kind of sign we get, what kind of number we get, either positive or negative, out of this product. Right? So we started with -2 in the first region. We plugged it in. -2 minus 2 is -4. -2 plus 1 is -1. The product, though, is +4, which is a positive result. So I get a positive result in the first region. All right? Does that make sense? Let's pick again. So let's test the second region then. Let's pick x to be 0. So let me do the work here. So let's let x. You can start doing this in your head a little bit too, by the way. You don't have to show all the work. If I pick x to be 0 and plug it in, I'm going to get what? I'm going to get 0 minus 2 for this product, right? And 0 plus 1. All right, and that's going to be what? -2 times 1. That's -2. All right, -2. So, but what's that? That's a negative number, right? That's a negative result. So negative. All right. So for the number, for the second region, for the numbers between -1 and 2, if I pick any number between -1 and 2, and I plug it into this product or to this left-hand side, I'm going to get a negative number out of it. Does that make sense? Right. So put a minus in the middle. So we have a plus for region 1 and a minus for region 2. All right. Okay, how about region 3? Give me a number for what's in region 3. Well, how about the number 5? How about the number 3? Anything bigger than 2 will do, right? So let's test that. Let me let x equal to, let me see if I can fit it in here into the small space I have left. Let x be, let's say, 3, for example, for the third region here, right? So let's plug it in. Well, that's going to be what? 3 minus 2 and 3 plus 1. That's going to be 1 times 4, which is positive. Right? Again, this is positive. All right, does that make sense? Positive. So if I pick a number in the third region, the result will be positive as well. So put a plus right there for the third region. All right. So these are the results of my sign chart. This is, by the way, this is called a sign chart. This whole thing here is called a sign chart. So for my sign chart, I have the following results. This product is positive in the first region. This product is negative for numbers plugged in from the second region. This product is positive for numbers plugged in from the third region. All right. So what do we want though as our solution? Well, remember we want this product, right? X minus 2, x plus 1 to be what? Greater than or equal to 0. What numbers are bigger than or equal to 0? Are they the positive numbers or are they the negative numbers? Well, clearly the positive numbers are the numbers we want, because positive numbers are what? Greater than or equal to what? 0. So the solutions are going to be right here. So solutions are going to be in the first region and what? The third region. Not in the second region. Not in the second region. Okay, does that make sense? Sorry for the mess here, but again, hopefully you can see that all we're doing is what? We're factoring the left-hand side, all right? And then we're going to figure out the boundary values from that and make our sign chart, all right? By testing numbers in the three regions as mentioned to see what results we get, positive results or negative results. Now, had this inequality been less than 0, then the negative numbers would have been what we wanted. But since we want this product to be greater than 0, or equal to 0, that is, then we want the positive numbers. Now, speaking of equal sign, by the way, that has implications on the boundary values, right? Because remember, the boundary values 2 and -1 will make this product equal to what? 0. So since it can equal 0, we do want these two numbers, these two boundary values, to be included in the solution. So my solutions are going to be what? Everything from -1 to -infinity, or +2 to +infinity. So we're saying that solution, if I write this in interval notation, for example, it's going to be from -infinity up to what? Up to -1, including -1, right? Because we have an equal sign on 0, right? And also 2 to infinity. So union, right? Including the 2 to infinity. All right. So let's do another one to give you a better idea of how to create the sign chart once again. And again, the theme is going to be factoring here to solve these nonlinear inequalities. All right. So this is the solution. Now, if you're writing this in interval in set builder notation, it'll be what? All real numbers x, such that either x is less than or equal to -1, or x is greater than or equal to what? 2. Sorry, squeeze that in there. Running out of space. But you get the idea of what? Interval notation and set builder notation once again. All right, let's go ahead and try another one. Let me go and clear out the screen. Take a look at this one then. All right, take a look at 4x squared. 4x squared minus 9x plus 2 less than 0. All right, less than 0. So let's go and try this one. All right, again, let's factor the left-hand side. So trial and error will go. All right. So I'll go 4x and x for 4x squared, right? And I'll put a 1 here and a 2 here for the 2, right? I want -9x out of that, so here's my 1x, here's my 8x. That will give me -9 if they're both negative. So not too hard. Again, just recall the factoring concepts of trial and error on this, right? We've seen this in the past. All right. Anyways, what's the next step then? Well, the next step is to figure out the boundary values. So let's look at the boundary values. Again, what are these values again? These are the values that make the factors that I have here equal to 0. So if 4x minus 1 is equal to 0, then if I solve for x by adding 1 and dividing by 4, wouldn't it be x equal to 1/4? Yes, it would. So there's the first boundary value. All right. Let's look at the next boundary value. Well, x minus 2 equal to 0. Again, we've seen that already. Solve in our heads, you get 2. All right, no big deal. So my number line then will be the following then. Here's my number line. It's going to be what? 1/4. So put them in order though, right? 1/4 first and then 2 second. So 3 regions to test. Okay, here's region 1, here's region 2, and here's region 3. All right? What will the sign be for each of these 3 regions for this product? All right? Well, again, let's pick numbers in these so we're picking numbers in the 3 regions again. So again, pick numbers in each region. So this is how we make the sign chart to test the sign. Test the sign of the product. Sign of the product. All right. So again, let's figure out what's a number in here. Well, how about what? What's less than 1/4? Well, good number will be what? 0, right? Let's let x be 0 for the first region. So this is for region 1. All right. So if x is 0, let's plug it in. 4 times 0 is what? 4 times 0 is 0, so that's just -1. -1, 0 minus 2 is what? -2. All right? So that product is +2, but that's what? That's positive, right? So put a plus right here. Can we see that? Let's go ahead and pick a number in here. What's between 1/4 and 2? Give me a number between 1/4 and 2. How about 1? 1 is a good choice, right? So for region 2, I'm going to test x equal to 1. Let x be 1, because that's between 1/4 and 2, to test the sign. can plug it in because it's easy to plug in 1, right? So we're going to get what? If I plug 1 in, 4 times 1 is 4, 4 minus 1. So that's basically 4 minus 1 times what? 1 minus 2. 1 minus 2. Alright? So that's 3 times negative 1. But that's a negative number. That's negative 3, which is negative. Minus, right? Put a minus right there. So put a minus in the middle here. Alright? Give me a number in here. Well, again, let's pick 3. So for region 3 again, I'm going to let x be the number 3, which is bigger than 2. Alright? So let's plug it in again. So we're going to get what? 4 times 3 is what? What's 4 times 3? 3 is x now, right? 4 times 3 is 12, right? So 12 minus 1 times 3 for x, right? 3 minus 2. Again, I should write this product over here. So let me squeeze it in here. 4x minus 1 times x minus 2. That's what we're testing here, okay? So I'm picking 3 for x. 3 minus 2 is going to be 1, isn't it, right? Okay, so we're going to get 11 times 1, that's 11, but that's positive. So put a plus right there. As you can see, though, the signs alternate between the two regions, right? If it's plus in the first, then it'll be minus in the second, and plus in the third. Does that make sense? So you can sort of use that fact to help you guide you along the way in terms of do you have the right sign or not, right? So it doesn't always happen, but typically that will be the case. They will alternate in sign. All right. Anyways, I want this to be strictly less than 0. Right? So do I include the endpoints? Do I include the boundary values, in other words, right? No, I do not. Since I do not include them, let me put an open circle on the boundary values. So I'm not going to include the 1/4. I'm not going to include the 2 in my solution because there's no equal sign here on 0. All right? But what else do I want? Do I want the positive results or do I want the negative results? Well, here's the product, and we want the product to be what? Less than 0. Well, numbers that are less than 0 cannot be positive. They have to be what? Negative, right? So that's the solution. So this is the solution right here. All right? So basically, the solution is going to be what? All real numbers between what? 1/4 and 2. Not including them, right? Not including them. In other words, we're saying what? 1/4 less than x less than 2 is the solution. So if I'm writing the solution in set builder notation, it'll be all real numbers x such that 1/4 is less than x, which is less than 2. So all real numbers between 1/4 and 2 will make this product less than 0. And so that's what we want in terms of the solution. Now, what about interval notation? Well, just parentheses 1/4, comma, what? 2, parentheses. Okay? So no big deal for interval notation. So either notation you should be familiar with by now. All right? So again, the key is to know how to create the sign chart to analyze the product of these two binomials. All right, so let's go and try another one here. Let me go and clear out this screen here. Let's go and try another one. Let's clear out the screen here. All right, let's take a look at this one here. How about x cubed? X cubed minus x squared is less than or equal to, this time. How about 4x minus 4? 4x minus 4. All right? Let's go and try this inequality. Now, this is different from the ones we've seen in the past because, first of all, it's a third degree polynomial, x cubed, right? But more importantly, the right-hand side is not what? It's not 0. So we need to zero out the right-hand side before we begin the factoring process. So don't just factor this left-hand side. You need to zero out this right-hand side. Just bring the 4x and then minus 4 over to the other side. So how do we do that? Just subtract 4x on both sides. And what else? Add 4. So minus 4x plus 4 on both sides to zero out the right-hand side. Now we can begin the factoring process and the sign graph process. So x cubed minus x squared minus 4x. These are not like terms, just bring them down. Plus 4. All right, we're okay on that? All right, how do we factor that? Well, 4 terms, right? How about by grouping? Grouping for 4 terms. So this will be x squared coming out. We've done this in the past, so x minus 1. Let's take out a negative 4 on that one. So you're going to have x. Now, be careful here, since I took out negative, to get back positive, I need a minus 1 in there, right? Negative 4 times negative 1 is positive 4. So make sure you put a minus there. Less than or equal to 0. All right? So that means what? They have x minus 1 in common, so I'm going to take that out. So what's left? X squared minus 4. All right? Less than or equal to 0. But that's also that's also factorable here, right? This is difference of squares. So x minus 1 times x plus 2 and x minus 2, as you already know. All right? But look at this now. Instead of having 2 factors, we now have 3. So we have 3 boundary values here, right? So boundary values are going to be 3 of them, right? There's going to be what? There's going to be positive 1 there. There's going to be negative 2 there. And positive 2 here. All right? So if you're making the number line, okay, down here, you need to include all 3 of these in the proper order, of course. So here's negative 2, here is 1, and here is 2. All right? So a little bit trickier on this problem since there's 3 boundary values, which means what? How many regions do we have now? Well, not 3 like we had earlier, but what? 4 regions. Here's 1, 2, 3, and here's the 4th region thrown in. All right? So we have 4 regions to test now for the sign of this product. So you might want to put the product here on the left. I'm running out of space, so I'm not going to do that. But just refer to these 3 factors on top. Now, let's talk about the boundary values. Am I going to include them in the solution? Well, there's an equal sign here, right? So therefore, if there's an equal sign, you are going to include, let me put a closed circle, you are going to include these 3 numbers. These 3 numbers you found, these 3 boundary values. All right. Again, just figure out what signs go with these 3 regions again, right? So again, mention that you really only have to test one of them because they alternate in sign, but we'll test all of them just for completeness sake. All right. So let's pick a number in this region here. Well, give me a number in the first region. What's a number less than negative 2? How about negative 3? If I pick negative 3, if I plug in negative 3 for x, what do I get? Let's just do some work here. On the side here. So negative 3 for x, all right, for the first region. What do I get? Well, negative 3, let me go ahead and just do the work in my head a little bit as well, though. Negative 3 minus 1 is what? Negative 4. Negative 3 plus 2 is what? Negative 1. What's negative 3 minus 2? Negative 5. All right, if I plug in negative 3, you should get these 3 numbers. But what's the product? The product is what? Negative 20. Or negative result. So you get a negative result in the first region. So it should be negative, so it should be what? Minus, plus, minus, plus. Let's verify that. Give me a number in here, second region. Well, give me a nice number, in fact. How about 0? 0 is between negative 2 and 1, right? So let's test it. Let's pick x, let me squeeze down here, x equal to 0 for the second region. All right? So let's plug it in. If I plug in 0 for x, then it's just negative 1 times 2 times negative 2. If I pick 0 for x again, right? That's positive what? Positive 4, so plus. Put a plus right there. So it's going to be plus right here in the second region. So this product is going to be positive, in other words, if I pick a number between negative 2 and 1. All right? What about number between 1 and 2? That's trickier, because what's between 1 and 2? How about 1.5? How about 1.5? All right, let's pick 1.5. I ran out of space. Let me do it up here. So let's take x to be 1.5 or 1.5. Let's plug in 1.5. You can use your calculator for this, but I don't think it's really that necessary. But let's do it. 1.5 minus 1 is going to be what? 0.5 if I plug it in, right? What's 1.5 plus 2? 3.5, right, if I plug it in. What's 1.5 minus 2? That's going to be negative 0.5. All right? Can we see that? So negative 0.5, you plug in 1.5 minus 2 there on the punch out into the calculator. But anyways, regardless of what this product is, can we see that positive times negative will be what? Negative. Okay, so I don't even have to work it out now. So the result's going to be minus. And again, they alternate in sign, as you can see, right? So it should be positive over here. But again, we'll verify it. Let's test over the fourth region. Again, what's a number bigger than 2? How about 3? All right. If I pick 3, what do I get in this product? 3 minus 1 is what? 2. What's 3 plus 2? 5. And what about 3 minus 2? 1. Again, that's 10, which is positive. So plus, as we suspected. All right. Now, What do we want? Do we want the negative results, which is here, 1 and 3, or do we want the positive results, which is 2 and 4? Well, the regions 2 and 4 I'm talking about, of course. So go back to the inequality here, right? Look at this. We want this to be what? Less than or equal to 0. So we want the negative results, right? We want the negative results as the solution. All right? So we want these two regions, since they are the solution to this product, to this inequality. Okay, then how do we write this in interval notation? I'm not going to write set builder anymore. Well, I'll do both. That's right. This problem's a little bit more complicated, so I'll do both for you. Let's do interval notation. So interval notation, so solution is right here. Everything less than -2, so -2 from negative infinity up to -2, and everything between what, 1 and 2. Okay, so interval notation, it'll be what, negative infinity up to -2, including it, right? We're including the endpoints now, right? Because there's an equal sign right here. Union, right? Union with what? 1 to 2, including 1 and 2, of course. That's the solution. How do we write this in set builder? All real numbers x, such that x is less than or equal to what? -2, or between 1 and 2. So 1 less than or equal to x, less than or equal to 2. All right. So make sure you know how to write in set builder as well as interval notation. All right. So, but the key is what, know how to make this sign chart, and then come up with the boundary values, right? So, I mean, know how to factor it, come up with the boundary values, and then make the sign chart. Okay. Let's go ahead and look at a fractional one. That's a bit more tricky. Let's go and try this one. I'm going to clear out the screen. Take a look at this one. How about x plus 2 over x minus 3 greater than or equal to 0. Okay, let's look at that one. A little bit tricky here with the fraction. No factoring here because why? Because these aren't factorable, right? So we can go straight to the boundary values. Boundary values. And the boundary values are going to be what? For the numerator, will be what? -2. For the denominator, will be what? +3. All right. Now let's make our number line then, right? So let's look at the real number line. Let me put up here. So here's -2. Here's +3. Now 3 regions to test them, right? Here's region 1, region 2 in the middle, and region 3. 3 regions to test. All right. Now am I going to include these boundary values? Well, yes, I am, because of the what? Equal sign. But be careful with this quotient, right? This is a division problem. If I plug 3 in for x, that'll make the denominator what? 0, which is undefined because you can't divide by 0. So we should not include this 3 in the solution. We do have to include the -2 though, because -2 plus 2 is 0 on top, but it's okay to have 0 on top for a fraction. Remember that. But it's not okay to have a 0 on the bottom for a fraction. So we're including the -2, so closed circle, but not including this 3. So make an open circle at 3, meaning that we're not going to include the 3 because it makes this fraction undefined. All right. So again, key concept there, right? Include the -2 because of the equal sign. If there's no equal sign, then both will be open circle, of course, and then I don't even have to worry about this concept. But since there's an equal sign, I do have to include the -2, but I'm not going to include the 3 because I don't want this fraction to be undefined. All right. Hopefully that makes sense. All right. Now let's test the 3 regions as we've done previously. No big deal. So let's give me a number in here. What's a number less than -2? How about -3? Well, plug it in. So we're going to get what? -3 plus 2 over -3 minus 3. That's going to be what? -1 over what? -6 here, right? That's positive 1/6. Positive, right? Key is what? Plus. Don't worry about the 1/6, the number itself. Just know that the result we need, though, is the positive result. Okay, so just know that we want the positive. We want the result, right? Not the number itself, but is it positive or negative? Most importantly, and this 1/6 is obviously positive. So put a plus in the first region. Again, they typically alternate signs, so it should be plus, minus, and plus. But well, again, you should always verify just in case you get a special type of polynomial which doesn't quite pan out that way. But I think for the homework problems, it should basically pan out this way. All right, let's go ahead and test what's the number between -2 and 3. How about 0, right? So let's test the number 0. X, let's pick x to be 0. Let's plug it in. So 0 plus 2. So again, the theme here is what? Picking a number in the 3 regions and plugging it in to test the sign. In this case, we're testing the sign of the quotient, not the product. But basically, the theme is the same. So 0 plus 2 and 0 minus 3. That's going to be 2 over -3 or -2/3. More importantly, minus is what we're getting at. Minus. So put a minus right here. Okay. Again, they should alternate in the sign as I talked about. All right, what about region 3? What's the number in here? What's bigger than 3? How about 4? So let's test x equal to 4 here. Let's plug in 4 into this quotient. So 4 plus 2 over 4 minus 3. Again, that's 6 over 1, which is 6, but again, the key is what? Positive. So we get plus. Again, they should alternate in sign, so that's the correct sign graph. That's the correct sign chart for this. And again, what do we want? We want the positive ones or the negative ones? Well, we want this quotient to be greater than 0. So those are the positive results. We want the positive results here. So the solution will be what? Negative infinity to -2, including -2. 3 to infinity, but not including 3. So again, I'll just do interval notation here. So it'll be negative infinity up to -2, in bracket, union with what? 3, not including 3, to infinity. Okay, so that's my solution here. Alright, so hopefully we can see that. So again, the key is to make the sign chart regardless if it's a product or a quotient, then come up with the solution from the sign chart. Okay, so hopefully that's not going to be too bad in terms of that. Alright, let's go ahead and do one more here. And then I'll give you the problems to post into Blackboard. Let's go and try this one. I'm going to clear out the screen. Alright, let's go ahead and look at how about x minus 1 over, let's say, x squared. Let's see here, how about plus x minus 6. Let's make it greater than 0. Okay, let's go and try that one. So what makes this fraction bigger than 0? Our positive number. So we want the positive results, right? Can we see that? All right. But let's go and factor this. So this is going to be what? X plus 3 times what? X minus 2. Hopefully we came up with that without too much difficulty. So the boundary values are going to be what? So the boundary values, BV for boundary values, right, are going to be what? Positive 1, negative 3, and what? Positive 2. All right. No equal sign, so we're not going to include any of these. They'll be open circles. So in other words, if I'm making my sign chart here, let me arrange this in order, of course. Here's negative 3, here's positive 1, here's positive 2. And it's going to be all open circles on them because there's no equal sign on the inequality anyway, so we're not going to worry about dividing by 0 because we're not going to here, since I'm not including these boundary values. All right, hopefully that makes sense. But anyhow, what are the signs going to be? Now, how many regions? 1, 2, 3, 4. So 1, 2, 3, and 4 regions to test now. Okay, so 4 regions to test here. So again, just pick a number in each of these 3 regions and each of these 4 regions, excuse me, and see what the sign is. Okay, so let's test the first one. Give me a number less than -3. How about -4? So let's test x equal to -4 here. Let's plug it in. So we get -4 minus 1 over what? -4 plus 3. And -4 minus 2. All right, just plug it in to these 3 factors, if you will. Right, you can put a parenthesis around that if you wanted to. But that's going to give me -5 over what? -1 times -6. All right, so again, -5 on top. That's -1 here. -4 plus 3. -4 minus 2. -6. That's going to give me what? -5 over positive 6, or -5, 6. Again, don't worry about the 5, 6. Mainly, just know that it's what? A negative result. Negative result. So this is going to be minus here. All right. Let's test one more, and I'll just show that they're going to alternate in size. I'm not going to test the others. So let's plug it. Give me a number in the second region. What's between -3 and 1? How about again 0? Let's pick 0 for x. 0 here for the second region. All right. Let's plug it in. So we're going to get what? 0 minus 1. All right. 0 minus 1 over what? 0 plus 3, and 0 minus 2. Picking 0 for x here to test the second region once again. All right, that's going to be negative 1 over 3 times negative 2, negative 1 over what? Negative 6, or positive number here, positive 1, 6, so plus here. So put a plus here, and the third one region is going to be negative, fourth region should be a positive result. Okay, they alternate in signs I talked about, so I'm not going to test it, but you're welcome to test it. You can pick x to be 1.5 here, between 1 and 2, and 3 for x, that's bigger than 2, to test the third and fourth regions, but I'm not going to do it here. Anyways, the results we want, though, what? Are the positive results, greater than 0, right? So we want the positive results right here. So solution will be what? Between negative 3 and 1, not including those endpoints, and 2 to infinity. Can we see that? So interval notation will be what? Negative 3 comma 1, parentheses, since we're not including them, union with what? 2, not including 2, to positive infinity. Okay, so this is my solution then. Alright, so again, get comfortable with how to create the sign chart. Key is what? Figure out the boundary values, test it out, be more careful with the quotient situation, but the theme is basically the same. Alright, let's go ahead and clear out the screen and give you some problems to do on Blackboard and post the solutions to. Right, let me go and clear out the screen. Alright, let's go and solve then the following problems and post them into Blackboard here. So number 1, let's go and solve the following inequality. 8 minus 7x minus x squared is less than 0. Okay, so there's the first one. Tricky to factor, but hopefully we can do it. Trial and error. Number 2, how about 2x cubed plus 3x squared, alright, greater than or equal to 8x plus 12. So 2x cubed plus 3x squared greater than or equal to 8x plus 12. So you have to what? Zero out this side before you zero out the right side before you begin the factoring process. Alright, number 3, how about fraction problem here? X minus 5, this quotient here. X squared over x squared plus 5x minus 6. I want this to be less than, how about less than 0 here. Alright, so solve these 3 inequalities and using the sign chart that we talked about, and post these solutions, probably using interval notation here, or set builders, up to you, but I prefer interval notation, and post it into Blackboard. Alright, so we'll go over in class, and until next time then.